Hello everyone and welcome to this new video. In this video we are going to talk about how name-based virtual hosting works in HTTPS connection. But before we move to this new topic, let's do a quick recap of what we discussed in the previous lecture. In the previous video we discussed in detail that name-based virtual hosting allow multiple websites to run on a single server and IP address. We had used NSLOOKUP and Postman to understand this concept. We also discussed in the previous video that even before the HTTP request is sent, there is a network process called the TCP handshake takes place between the client and the web server. And once this three-way TCP handshake is complete, the connection gets established and the client sends the HTTP request containing the host header. For HTTP, the host header in the request tells the server which website the client wants to visit. And the web server looks at the host header in the request to make the routing decision in name-based virtual hosting. Alright, let's now talk about name-based virtual hosting in HTTPS and try to understand why this situation becomes a bit more complex in HTTPS. In this diagram, as you can see, we are going to talk about the different handshake process between the client and the server. So whenever we try to access a secure HTTPS website, first DNS lookup occur to resolve the domain to the IP. Then TCP handshake occur and the TCP connection gets established. So this is the TCP handshake. The TCP handshake is followed by TLS handshake between the client and the server. It is during this TLS handshake that the server has to prove its identity by sending the server certificate to the client. And only after this TLS handshake, an encrypted channel is formed to secure the communication between the client and the server. So this is the place where the application data is exchanged. As you can see, the SSL TLS handshake happens before the HTTP request is sent. The server has not even seen the host header because the host header is sent as part of the HTTP request in the application data. So the server has no access to HTTPS host header. Now if multiple HTTPS websites are sharing the same IP address, how does the server know which SSL TLS certificate it has to present to the client during the TLS handshake? So certificate selection is the other challenge that is faced during the HTTPS deployment for virtual hosting. Each HTTPS website has its own unique certificate to prove its identity. If the server presents the wrong certificate, chances are that the client will terminate the TLS handshake if it strictly validates the server certificate against the host name it is trying to connect, because certificate's domain name won't match the actual host name the user is trying to access. So server faces this dilemma like how to know which site's certificate to use in the TLS handshake. Let's quickly understand this concept using office building security analogy. Think of the situation like this. You arrive at a large office building and this office building has many companies on its different floors, and then you tell the security guard you want to visit a specific company. The security guard needs to know which company you are there to see before he can issue you a security badge, access badge, and can direct you to the correct floor and office. Similarly, in the internet world, the web server is like office building. It has its own IP address and a server, and it hosts many different websites. And it needs to know which website you are trying to reach before it sends the correct certificate to the client for the right website. Without a mechanism in place during the TLS handshake, the server wouldn't know which certificate to use if multiple HTTPS websites are on the same IP address. And this is where SNI comes into play, which we are going to discuss now. So SNI, also known as server name indication, enables multiple secure websites to share a single IP address. I will just quickly explain you TLS Handshake, a trimmed down version of TLS Handshake, before we proceed further from here. So to understand carefully, again there is a client, there is a server. Okay, so client, and here we have server. So the TLS Handshake starts with a ClientHello, the first message. In this ClientHello, one of the TLS extension that is sent by the client is SNI, which is nothing but server name or host name. There are other details also that is sent during the ClientHello, that is the protocol, cipher, sequence number and random number, but I'm not going into those details because the focus of this lecture is only to discuss the SNI. So that's why I mentioned at the start that I'm going to only share the trimmed down version of the TLS Handshake. So in the ClientHello, the client indicates the SNI TLS extension, which is nothing but the server name and host name, and based on this, server sends the server hello and server certificate. What server does is, server takes a look at this SNI, and then based on this SNI it chooses the right certificate that it needs to send as part of the TLS Handshake. Remember that encryption has not yet started, because encryption only starts after the TLS Handshake is finished. So now after the TLS Handshake is finished, this encryption starts where the application data is sent, and here the host header is included, and but this host header is encrypted here. So this entire section that you see in TLS Handshake is encrypted, but with SNI the server is able to select and present the correct certificate to the client. So as we just saw in the previous diagram, how SNI solves the problem is that client initiates ClientHello with SNI extension. So client sends the intended hostname during the TLS Handshake. Then second one, server identifies the site. So based on that SNI TLS extension, the hostname, server identifies the requested hostname, and then server selects the matching certificates for that website when there are multiple websites installed on the same server, and then browser verifies the certificate matches with the requested domain that it is trying to access, and then the encryption channel is established between the client and the server using the correct certificate. So to summarize, what are the problems that SNI solves, right? So we know that pool of IPv4 addresses are limited. So by supporting the deployment of multiple HTTPS websites on a single server IP, this SNI actually helps to achieve, with the help of SNI, we are able to achieve the deployment of multiple HTTPS websites. Second is, it enables the virtual hosting without needing a separate IP per site. Right? So in the event if this wouldn't have been possible, if the SNI wouldn't have been there, then the only way to achieve the HTTPS deployment was to have a single IP per website, which was not a practical solution, as you know that we have limited IPv4 addresses only, right? But with SNI, it helps us to enable virtual hosting without needing separate IP per site using SNI. Third is certificate complexity. So how you saw how correct certificate selection during TLS Handshake is now possible using the SNI TLS extension. So that was the magic of the server name indication SNI. I hope you would have liked this video, and if you have liked this video, then you can subscribe to my channel to get more useful content related to security. I'll see you in the next video. Thank you.